welcome to the live stream for India's new rocket that they're going to be debuting today. Um, yeah, so they have a new rocket that they've developed. Specifically ISRO, which is the Indian space, basically the Indian Space Agency. They have a lot of new rocket technology that they've been developing over the past, I would say, 10 to 20 years or so, and they're really making a lot of steps towards innovative development. So this is just one of those steps, and we're gonna hopefully get to see the first launch of this rocket and get to learn a little bit about its engineering and what's going on, and how it will be quite competitive on the global small satellite launch market as well. I'm really excited for this launch because it's just another step that's humanity in general is taking towards trying to bring down the cost of access to space. And we'll see that in a couple of minutes here about how it's been designed in a way to hopefully reduce cost for launching satellites, specifically the small satellites, because that's kind of like the new wave of the space industry right now, which is developing those small satellites which are using more modern technologies to, again, make things miniaturized and smaller. Because every single kilogram you put into space costs money, so it's always good to try to make things smaller and more efficient. So with that in mind, of course, India has developed this new launcher, and it'll be competing with other rockets, kind of like the Electron or Astra's Rocket 3, or Virgin Orbit's rocket. So those are the other kind of small satellite launchers that this vehicle will be competing with. So that's kind of good to keep in mind when we are watching this launch and seeing what's going on. So yeah, over the course of the build up here, we're going to be switching between the live stream, which ISRO is producing themselves, and also a little bit of content about why this launch is interesting, what the engineering of the rocket is, and kind of the important steps to launching the rockets and what you should be looking out for as you watch the stream. So yeah, and then of course once the launch is ready, we'll cut to the launch and hopefully see the success that it is. We're about 40 minutes away from the launch today, so you can always check to see if how far we are along in the launch proceedings by looking at the clock, which would be just down here. So it should be on most of the slides. If you want to see the clock, you can always just look there, and you can see how much time there is until we are expecting a launch. Yeah. So without further ado, let's get into it. So the first thing to look out for is the statistics of the vehicle. This is, of course, a new vehicle, so that the detail on it is a bit light right now. I suspect that things may change after this initial launch, but this is the design that they've gone with so far. Basically, it's a 3-stage rocket, which is a little bit different than the other rockets that are on this list of small satellite launchers, which are mostly just 2-stage rockets. So that means that there's 3 different parts, like 3 different rockets inside of this rocket. It's kind of like a Russian, one of those Russian dolls where there's a big rocket and then there's a little rocket inside of the big rocket and then a little rocket inside of that rocket. So basically what happens is when you launch, you start with the initial rocket, which has the booster on the bottom, and that when that runs out of fuel, it gets kicked off, and then the second rocket can kind of take off from there, and then so on and so forth with the third rocket. And the reason for doing this is basically once you get rid of all the fuel in one of your stages, like there's a whole bunch of tank that's left over as mass, and basically the more mass you take into orbit, the worse the rocket equation becomes for you, and you can't take as much payload. So a trick you use to do that is just to get rid of all of that mass by basically separating it and doing this staging sequence. And the propellant that this rocket is using is not quite as efficient in terms of fuel efficiency, so that's why they need to use kind of more stages in order to compensate for that. That's kind of the general idea of how staging works, I guess. The rocket itself is actually somewhat large. It's 34 meters tall, which is definitely, I would say, the largest small sat launcher that's on the market right now. So it's quite a big boy. It has a diameter of about 2 meters, which gives it a very large payload fairing bay. So that's actually really advantageous because that means it can fit more satellites into that area. And I think it's also the heaviest small satellite launcher at 120 tons. That's like kind of moving into the range of what uh, a mid-sized launcher would look like. But of course, this is just a small satellite launcher. But don't let that fool you. Just because it is a lot bigger, it doesn't mean it's going to cost more. So that's kind of something that's interesting about this launch in general. So moving into the propulsion system, here you see kind of the breakdown of how the stages are, and here's where they start to use that cost efficiency, because instead of making, 3 different rockets that are on each of the stages, they've basically just made 3 different sizes of the same rocket. So they're using the same fuel to propel each of these stages, and they kind of have the same similar design, which is to use solid motors. And what that means is basically they're using a solid propellant. So instead of having like a liquid that gets fed into the engines, you have basically a solid propellant that burns radially or vertically through the core of that booster. And basically none of the fuel is moving. It's like static there. It's stuck there in like a binder, and so it's kind of like no moving parts. And this really reduces the complexity and the cost, because you don't need to have pumps, you don't need to have expensive propellant management systems. It's basically you just have a tank, a thick outer wall that holds in the pressure of all that propellant that's burning inside the combustion chamber, and that's it. So it's like super simple. You just ignite it, and then away it goes. With that simplicity, though, you do lose a little bit of control, because once you start a solid rocket, you can't turn it off. So if you can't like throttle or change the duration of your burn on the fly or anything like that. It's kind of just push and go, and then hold on for dear life sort of a thing. But if you're clever about it, you can use this and still manage to get yourself into an orbit that you want to get into. So for instance, you can still do things like vectoring your thrust to have control over the vehicle. And you can see that they have little things to try to control the flight of the vehicle as well in the atmosphere. So they have these little tiny fins that are on the bottom that help the vehicle stay passively stable. And that reduces the amount of effort they have to put into controllability, because they're using, of course, these solid motors. You can also see the power of these stages. So like the first stage has 2.5 meganewtons of thrust, which is a ton of thrust for this type of a vehicle. So it's always really cool to see such large rockets being developed. And this one, of course, because it's so big, needs quite a lot of power. So that's basically the same power that you would have on a side booster for a medium or heavy lift rocket. So it's actually quite a monster, quite a monster of a thrust there. So basically, that's what's powering the vehicle anyway. Moving on to how will the rocket launch actually flow in terms of the steps that we're going to be taking throughout the launch. So like I mentioned before, it's a 3-stage system. So we're going to have like 3 steps of staging. So first we're going to have at T-0, which is going to be in just over 33 minutes here, we're going to have that first stage igniting. And like I said before, once that stage ignites, there's no going back. So you can't turn it off after that point, right? So they'll light the rocket, and then it's going to take off pretty fast off the pad. And that first stage is going to burn for about 90 seconds. And then after that 90 seconds is over, we're going to have the first stage separation. So basically that first stage is going to burn out, it's going to run out of fuel, and then it's going to be separated, and then you're going to see the top half of the rocket kind of take off from there. And it's also a solid motor, and it's going to ignite itself, and once it ignites, it's just going to go. None of this rocket is recovered. So I know one of the innovations that's going on in the launch market today is that they try to recover the rockets in order to make them cheaper. But the SSLV is kind of doing the opposite of this approach, where they're trying to make their rocket as cheap as possible, so that basically, throwing it away is really not that expensive because it's so cheap. So all the parts of this rocket will actually just fall back into the ocean. So nothing's going to be reused. There's no attempt to catch it with parachutes or do any sort of propulsive landing or anything like that. So everything will just fall back into the ocean. So once we've had that first stage separation, the second stage will of course ignite, and then it's going to burn again for about 100 seconds or so. And then we're going to, during that period, we're going to have the fairing deploy. So once it kind of gets out of the atmosphere, you don't really need to have that protective cover over top of the satellites that are traveling into space. So it basically jettisons that payload fairing, and that's going to allow it to reduce its mass a little bit and hopefully get a little bit more efficiency. So you should see that somewhere in the middle of the second stage flying. And then near to the end, once the second stage runs out of fuel, of course we're going to have the second stage getting pushed off, and you're going to have the third stage becoming ignited. So if there's like an even smaller rocket inside of that second stage that will also be doing a lot of the work to push this thing into an orbit. That one is also going to burn for about just over 100 seconds. So it's actually all pretty short. Like if you add up all the times that it's going to take to burn, it's like 90 seconds, 100 seconds, maybe like 120 seconds. It's like overall, it's like less than 6 minutes, which is a lot faster than you would have for a liquid system. So it just shows you that basically, because you're using solid propellant, you're getting way more thrust. It's just kind of like the nature of how the engineering works out. It's easier to get high thrusts with solid propellant, mainly due to like propellant density and stuff. Solids are obviously denser than liquids, so you can burn more at once. And yeah, because of that, you can actually like kind of get to orbit faster, I guess. So if you're impatient, it's a launch that happens relatively quickly. So then finally, once the third stage has finished burning all the way through, you're going to have basically the orbital insertion. And because solids are like kind of a little bit imprecise, this orbit will probably not be perfect. So there's also, on top of this third stage, some like orbital maneuvering thrusters that they have that can be used to kind of like correct the orbits and adjust the altitudes and the angles and stuff like that. It's not just used for orbital orientation, like orientation of the satellite and the bus itself. It's also used for like little changes to the orbit as well. And then that's just because there's impreciseness in the actual orbital insertion with solid systems usually. Yeah, there's like the computer can't compensate and be like, okay, just burn the engine for like half a second less because we're going a little bit too fast. It's like once you light them, they go. So that's the negative, I guess, of a solid system. But in the end, they're potentially a lot cheaper. So this could be maybe potentially a more innovative way to get satellites that are small into orbit. So we'll see. We'll see what happens with the overall competition and which system ends up being the most useful in the end, I guess. But yeah, let's see what's going on in the live feed right now.
अब हम प्रमोशन से 28 मिनट 54 सेकंड की दूरी पर
So it looks like we have the vehicle standing on the pad nicely. That's good to see. Now there's not going to be any filling. So that one thing that we're used to in these launches is to see like the vehicle filling, and you see like clouds coming off the vehicle and stuff. Because this vehicle is
SSLV small satellite launch vehicle एक लघु उपग्रह प्रक्षेपण यान है इसकी क्षमता.
So because the vehicle has basically solid fuel, you're not going to see any of those like filling clouds or anything coming off the vehicle, and that's just because like there's no propellant being loaded in. It's already all loaded up in solid form. So it's just sitting there on the pad, and it's not at any like special temperature. They don't cryogenically cool the fuel or anything. It's just all sitting at room temperature, ready to go. So there's kind of like less of a procedure that goes into actually getting the vehicle ready. It's more of a procedure to get the range ready and to get the electronics, figured out and make sure everything's all the sensors are working properly. But in terms of the propellant management and the engines and stuff, those are just ready to go.
में कई चुनौतियां आई. प्रभावी लागत तथा अल्प समय में तैयार की जाने वाली विश्वसनीय प्रमोचक रॉकेट बनाने की चुनौती इसमें शामिल है.
And if you're not watching from India, yes, most of the official live stream will be in, uh, I think it's Hindi that they do it in. So, of course, it's India. So,
P4 radiation on.
SSLV को मुख्यतः लॉन्च ऑन डिमांड के ध्यान में रखकर बनाया गया है. SSLV के प्राथमिक विकासशील उड़ानों के पश्चात NSIL इसे भारतीय उद्योगों के द्वारा बनाए जाने पर भी विचार.
They always like to show the lots of the mission control room on these ISRO live streams. So be prepared for that. But it looks like they don't have a clock here. So maybe
let's take a look at the SSLV
maybe we can add
integration
the
activities
clock
at
here.
SDSC Shar. The launch campaign began with the flag off of the nozzle end segment of the first stage from second vehicle assembly building to the mobile service tower. The movement of middle and head end segments. The joints being open type or dry type, minimum time is taken in the assembly of all the segments on the single day.
So you can see here like how it all comes together. They basically just like put it together like on top, one on top of each other, and they just bolt it all together. And these are the stages that they're bolting, like the different segments of the stages they're bolting together.
सभी खंडों को जोड़कर SS1 प्रथम चरण तैयार किया गया और अब इग्नाइटर को इसके साथ एकीकृत किया जा रहा है.
And that's the igniter that they're putting in. So like you can see how big that igniter is. Like it's basically another solid rocket essentially that they're putting inside of the motor to start the flame and get that thing burning.
एकीकृत कर लॉन्च पैड लाया जाएगा.
And this is now the upper stage. This is the second stage they're putting on. They basically have a like this honey,
the
like I don't know.
The second stage along with the interstages.
It's like this weird honeycomb interstage that you kind of like see through. It's kind of weird looking, but look out for what it looks like. You can kind of see it there. It's like a cage that the second stage engine is being carried in.
Minus 25 minutes.
द्वितीय चरण को एकीकृत कर लॉन्च पैड लाया गया है.
And you can see the simplicity of the tools they use a little bit.
प्रथम चरण के साथ एकीकृत कर दिया.
So here they just have like a little a truck to move these parts around. NASA would have like an official like special machine for it. They just use a normal truck, you know. You don't need special stuff.
और अब आप देख पा रहे हैं तृतीय चरण SSLV का यह तृतीय चरण एकीकृत कर दिया गया.
And that's the third stage. After the third stage, now you are able to watch the satellites being prepared.
So the satellite that they're missing.
That is the EOS-02 satellite and the Azadi Sat.
So this is actually a pretty small satellite. You can see it there. It's being integrated onto the top of the
EOS-02 उपग्रह तथा
inside of the payload fairing.
Azadi Sat को एकीकृत कर ऊष्मा कवच के अंदर सुरक्षित कर दिया गया.
And basically, yeah, it's a satellite that's been developed to do some like mapping and cartography type stuff.
Satellites being prepared.
And
this will be moved to the launch pad and integrated with the launch vehicle.
Yeah, you can see there. It's not super big, but it's like definitely way bigger for the payload fairing. It's like way bigger area and volume than most other small satellite launchers.
अब संयुक्त उपग्रह तथा VTM मॉड्यूल को लाकर MST में.
But they can definitely fit way more in there in terms of volume than what they're putting in there today. Like it's just a little 140 kilogram satellite.
अब MST मोबाइल सर्विस टावर को पीछे पार्किंग एरिया पर ले जाया जा रहा है.
Is this one curiosity of the vehicle in general?
Fully ready for its maiden mission.
One curiosity about the vehicle itself is that like it has this giant volume that it can fit satellites into, but it just doesn't have a lot of mass capability. So it can only do about 300 kilograms to sun synchronous orbit and 500 kilograms to low Earth orbit. So I think it's one of the only rockets that's actually going to be mass limited versus volume limited in terms of fairing space. So that might be a little bit interesting as well. So it'll have like different operational constraints when it comes to actually launching satellites.
विजिटर्स गैलरी की व्यवस्था उपलब्ध है। बहुत से लोग यहाँ आकर रॉकेट लॉन्च का आंखों देखा अनुभव लेते हैं।
So you
आज
can kind of see
यहाँ
here, if you can see
8,600 से
just under
ज़्यादा
the blue
दर्शक
part, under the blue part of
यहाँ
the rocket,
मौजूद हैं
and the
और
white,
आनंद ले
there's
रहे
a,
हैं।
you can literally see the steel,
आप सभी
like the
दर्शकों का यहाँ
cage
फिर से
with the
स्वागत है।
second stage engine kind of like sitting there. And you have to wonder, like, does that affect the aerodynamics at all?
Minus
It's very
22
curious
minutes.
why they do that.
RSD confirms data
अब
from
हम
state 2.
प्रमोशन से 21 मिनट 48 सेकंड की दूरी पर
It always looks like they have more chairs in the mission control room than they have space.
इस दौरान आपको प्रमोचक रॉकेट SSLV के बारे में कुछ जानकारियां दे दें।
Noted. TCTC, char 192 confirms.
You can also see the
Char
flame
192
trench from
post
this angle. Like you see the concrete flame trench below the bottom of the rocket. So basically, all of the exhaust is going to go straight down, and it's going to be directed out the sides of that flame trench. And so it should be pretty spectacular when it takes off. You should see like almost like an explosion coming off the base, and like all the smoke and flame coming out the sides.
3 खंडों से बना हुआ है।
Recast
इनमें
on.
कुल
Recast
निर्वात
on
प्रणोद
station.
2600
Changeover to
किलो
channel
न्यूटन
2
उत्पन्न
at
होता
T
है।
minus 20 minutes. No confirmation is needed to control.
CY to ROD, all range instrumentation systems are ready for SSLV D1 UOS-02 launch.
ROD, Roger.
TDP to ROD, mission computers and real-time network are ready for the launch of SSLV D1 EOS-02 mission.
ROD, Roger.
RSO to ROD, range safety systems are ready for the launch of SSLV D1 EOS-02
मार्च 2022 को SS1 का
ROD,
परीक्षण कर सतीश धवन अंतरिक्ष केंद्र में
This is
इस
vehicle
परीक्षण
director to
को
mission director.
पूर्णतः सफल किया गया था
SSLV D1 launch vehicle are normal. and
और
within
इसके बाद
specific-
So while we wait here for the last parts of the integration and setup to finish here, maybe we just go a little bit over some of the interesting elements of the comparisons between the SSLV and other small satellite launchers, and also we should probably talk a little bit about what they're putting on top of the rocket, the satellite they're going to be launching today. It's just a test launch, so I'm not sure that there's actually anyone actually paid for the satellite to be on there, but it's just a test payload with a small scientific mission. So just looking at the comparison between one of the most prolific small satellite launchers, which is the Electron rocket, you really see the difference in size immediately. The SSLV is nearly twice as tall and nearly twice as wide, and I think it weighs like over 4 times as much. So it's like quite a monster of a rocket in comparison to the Electron. The main difference here being that, like, first in the materials, so like Electron's made out of carbon fiber, SSLV is not. It's just made out of, I think it's made out of aluminum. So much heavier vehicle. It also, because it's using solid rockets, it has to have like thick walls in order to contain the pressure of the combustion inside of the combustion chamber. And so that means that they kind of have more mass that they have to carry as they're going on its way to orbit, which of course, again, means you need more fuel. So the rocket ends up getting bigger and bigger and bigger. And then on top of that, because they're using a fuel that is less efficient, which is the solid fuel, they're using the HTPB stuff. The Electron uses liquid oxygen and liquid kerosene, which is probably is much more energy efficient in terms of getting more bang for your buck. So it can kind of get away with being a lot smaller. But despite those size differences, when it comes to payload to low Earth orbit, they're quite similar in terms of what they can deliver. They also fly to the same orbits, LEO and SSO. So basically going in orbit low to the Earth, either equatorially, or a sun synchronous orbit is one that goes polar, so north to south, and it's a little bit higher. But where you see the difference, where you see the big difference is in the cost. So basically, the SSLV is about half the cost of an Electron. So potentially, that could be a little bit disruptive and could cause a lot of payloads to switch over to a cheaper vehicle in response to that. But of course, we have to see the reliability. It could be that this is a less reliable system. We'll see. Electron already has a basis of reality, of reliability behind it because it's launched, I think, like over 20 times now. So it's quite an established vehicle in the small satellite market. So SSLV still needs to build up that repertoire before it can really start to compete. But yeah, you can really see here that there's quite a different design philosophy that they've gone with the SSLV. And then next up, let's look at the mission that we have on board. So it's going to be this EO2 mission satellite that they have on top. And basically, it's just a little satellite, like I said, 140 kilograms or so. And it has these two infrared camera sensors on it that are basically just going to be doing photography of the Earth in the infrared. And they're going to be using that for like mapping and Earth observation type information that they're going to be using it for. Parts of the satellite were developed by school children in India, particularly girls. At least that's what ISRO is claiming anyway. So it's good to see a satellite that incorporates some educational things and gets children involved in the process and gets them excited about, designing something that goes to space. I think that that's a good way to try to pass on the knowledge into the next generations and get them inspired about flying to space, which is, of course, also part of the reason why we like to stream these launches. If you don't know already, I'm part of a group called ASTRA, and we're a student group in Germany, and we're trying to build a rocket right now that goes to space. So we're kind of also trying to inspire people to get involved in doing space-related things, even if you're not directly involved in the space industry. When you're a student, it's a great time to pursue new things and new ideas. And so, yeah, that's why we're trying to get involved there as well. But we also are excited to see more students and more people getting involved in space. And this payload is part of that because it's doing that exact thing in India. So hopefully we'll have a successful deployment and some of these people can see some of their things that they designed flying in space. All right, so we're coming up to closer to the launch now, just 14 minutes away.
हम आपको प्रथम चरण के बारे में पहले ही जानकारी दे चुके हैं। SSLV का द्वितीय तथा तृतीय चरण SS2 तथा SS3 कहलाता है। यह भी ठोस नोदक वाला चरण है।
-14 minutes.
यह PSLV के HPS3 चरण का व्युत्पन्न चरण है। SS2 तथा SS3 क्रमशः 7.7 टन तथा 4.5 टन के ठोस नोदक वाले चरण हैं।
It's really weird that they don't include a clock
SS2
in their
और
stream.
SS3 के पश्चात
I have to
ऊपर
say.
पेलोड फेयरिंग के अंदर मल्टी पेलोड एडाप्टर है, जहां उपग्रहों को रॉकेट के साथ एकीकृत किया जाता है। इस यान में एक और मुख्य तंत्र VTM नामक वेलोसिटी ट्रिमिंग मॉड्यूल है, जो उपग्रह को अंतःक्षेपण से पहले निश्चित गति तथा अभिवृद्धि प्रदान करेगा। इसमें 50 kg के
So
मोनोमिथाइल हाइड्रोजीन
that rocket trimming module that he was just mentioning about is actually that like kind of fourth stage that I was talking about, where they have some fuel on board to perform some orbital maneuvers once they've delivered that payload into orbit. That's just because the solid rockets are kind of somewhat imprecise, so they need that like extra controllability and maneuverability in order to compensate.
इस यान में कम से कम लेकिन विश्वसनीय तंत्रों का इस्तेमाल किया जा रहा है। अंत में पेलोड फेयरिंग के एकीकृत होने के पश्चात SSLV का उत्थापन भार करीब 120 टन तथा लंबाई 34 मीटर की होती है। SSLV को बहुत ही सरल यान बनाने के लिए इसमें SSLV के सेगमेंट्स को ड्राई जॉइंट प्रक्रिया के साथ जोड़ा गया है।
The rocket also doesn't need much support
यहाँ
on the
ऐसी
launch
सुविधाएं
stand.
उपलब्ध हैं जिसमें कि कई सेगमेंट्स को एक साथ कास्ट कर बनाया जाता है।
And that's just because it's a solid rocket, so it's like the walls of its tanks are so thick that it can just basically stand on its own. Almost like a building. It basically looks like a building just standing there. A flying
आपकी
building.
जानकारी के लिए SSLV D1 को 1 अगस्त को इसका एकीकरण शुरू किया गया था तथा आज 7 अगस्त को हम तैयार हैं इसके प्रमोशन के लिए।
It's hard to tell from that perspective of that shot, but that rocket
Speaking
is
about the launch
34 meters
sequence
tall.
for today's launch, the ignition of the first stage, SS1, coincides with the T0. The first stage takes the launch vehicle to an altitude of about 90 kilometers. The second stage, or the SS2, ignites at 126.7 seconds, and there is a hot separation of SS1 0.4 seconds later. Then at
Minus 11
132
minutes.
seconds, there is the separation of interstage S2C. By now, the launch vehicle is at 100 kilometers altitude, so the closed loop guidance is initiated and the payload fairing separation takes place. The second stage, that is the SS2, burns out after an action time of 119 seconds but continues to coast along with the ongoing vehicle for another 91.9 seconds and then separates. The third stage ignites at 143.5 seconds and operates for 112 seconds. The coasting phase continues for 176.5 seconds and then SS3 separates. The altitude for the satellite is almost achieved by now, and the liquid-powered velocity trimming module operates for about 20 seconds to provide the correct attitude and velocity for the satellite
10
injection. Next comes the injection of EOS-02, the prime satellite for the mission, and then injection of Azadi-Sat, the co-passenger satellite, in the same orbit.
So a couple of interesting things there. You notice that basically it's going to be doing these coast phases. So essentially between the, here, let me show you here. So between the jettison of that second stage and the ignition of the third stage, there's going to be a coast of about 90 seconds. And the reason for that is that basically the rockets are so powerful that they're actually kind of like overshooting where they need to be in order to ignite the rocket next. So they're going too fast for that moment. So they kind of just go through a bit of a coast until they're in the right position to kind of start up that third stage and continue on the way to orbit. Because the goal is to get your speed going all parallel to the Earth. And so you kind of have to make sure that you're tilted in the right way to make that work. And so the trajectory that you're on after that second stage burn is actually a little bit too going upwards, and you kind of have to wait until you're more parallel to the Earth again to ignite that third stage. So it kind of goes through these coasts between the second stage burning and the third stage burning in order to allow for the correction of the trajectory. This is not a problem you have usually with liquid rockets because they're not powerful enough. It's usually the other way around, where they have to actually burn a lot longer than you expect because of the fact that they're somewhat weaker. So again, a difference in the way the whole mission is approached and a difference in the way that they actually come to the solution for getting to orbit. Yeah. The first stage is not going to be recovered, unfortunately. So there's going to be 3 stages burning, like I was mentioning before with this stage setup. So we're going to come here to the orbital insertion, and that's when the third stage finishes. None of the stages are recovered because it's all just a throwaway vehicle, basically. So there's no like recovery systems added on. The goal is to make this thing as cheap as possible so that they can launch it rapidly and repeatedly. for costs that are less than other small satellite launch costs right now. It's not the cheapest rocket on the market. Technically, Astra's rocket is a bit cheaper, but yeah, Astra hasn't really been so successful in launching rockets, so maybe SSLV is a better approach. We'll see. Yeah, so yeah, we have 3 stages burning, and just like the sequence of events that you saw them mentioning, we're going to go through those with the timings that we mentioned as well. But look for those. Don't be freaked out by the delays that will come between the stages igniting, between the second and third stage especially. It's not a bad thing. It just means that basically you have to wait until the trajectory is right to fire up those engines. Yes, all 3 stages are exactly the same type of fuel, which is really interesting and not so common, I guess, with these solid rockets. But this is, again, making it as simple as possible. They all use this HTPB derivative fuel. They've been a little bit playing their cards close to their chest. They haven't specifically stated exactly what the fuel formulation is, but I suspect it's probably some sort of HTPB aluminum binder mixture that they're using, mixed in with some ammonium perchlorate or something. That's probably the most likely propellant mix. This rocket is potentially derived from a military rocket that India uses, so this is probably the reason why they're not like outright telling you what the fuel mixture is. So yeah. So yeah, let's go back to the live stream here. We don't want to miss it.
In stage is Heritage HPS-3 motor powering the PSLV as third stage with certain adaptations. This is also a solid propellant stage. SS2 has a diameter of 2 meters and length of 3.2 meters. It has 7.7 tons of propellant loading inside a carbon fiber filament wound case. It is capable of generating maximum vacuum thrust of 235 kilonewtons. The third stage is a newly developed solid motor with 4.5 tons of HTPB based propellant loading, capable of developing 160 kilonewtons maximum vacuum thrust.
So they're saying it's newly developed,
SS3
but
also is a carbon filament wound case having 1.7 meters diameter and 2.8 meters length. To
So
ensure precise satellite injection into the intended orbit, a liquid bipropellant-based velocity trimming module is used. It has monomethyl hydrazine and mixed oxides of nitrogen as fuel and oxidizer respectively. The propellant of VTM also aids in the roll control during the SS2 and SS3 flight regime and control of pitch, yaw and
that's
roll
interesting.
during the coasting phase. SSLV has an encapsulated assembly comprising of VTM, satellites on a variety of payload adapters ensconced in the heat shield halves. The heat shield is of ogive shape made of composite with co-cured cork thermal protection system. Overall, the SSLV is 34 meters tall, 2 meters in diameter, and has a liftoff mass of about 120 tons.
Which is gigantic. She had mentioned that the engines are newly developed. That's not entirely true. They are like, of course they're newly developed for this specific rocket. They haven't been used in this type of way, but they're heavily derived from previous solid motors which are being developed in India. It comes from one of the missile systems. I'm not sure exactly what the name is. It might be the Vicus that you're mentioning there, but I'm not too familiar with all of the Indian missile technologies that are out there. But yeah, basically the propellants that are being used are exactly the same in all 3 stages, and the only thing they're changing really is the nozzle size, essentially. So it's very much the same. It's carbon fiber plus motor, carbon fiber plus motor, carbon fiber plus motor, just different sizes of nozzles, and they just kind of segment them all on top of each other, as simple as they can. They even have this crazy like cage structure that they have around the second stage. So it's not even, it's actually just open. Like it's not even a solid completely solid material. You could, like, a bird could fly through there. Yeah, I think you're right. I think it is the Vicas. That's ringing a bell as correct, but don't quote me on that. Yeah, the Vicas is kind of like a little short missile, I believe. So I think they've basically just extended that, and you know, you have your rocket then. Now it goes to space. Yeah, a more noble cause, I would say.
अब हम प्रमोशन से 2 मिनट की दूरी पर
The tracking of the launch vehicle during the flight is done
Minus
by
2
the
minutes.
ISRO Telemetry Tracking and Command Network called the ISTRAC. The SSLV D1 EOS-02 being a southbound mission, 6 tracking stations are participating. They are Shar, Bangalore, Trivandrum, Port Blair, Singapore and Yattaragga. These tracking stations have overlapping visibility to track the flight trajectory and staging events.
Okay, hopefully we get to. I hope they have some cameras on this thing.
We are 1 minute 30 seconds from the launch.
All right.
आज का मौसम यहाँ बदली वाला है। यहाँ जो दर्शकगण आए हुए हैं लॉन्च को देखने के लिए उन्हें थोड़ी दिक्कत हो सकती है।
The main difference between missiles and satellite rocket launches is size. So missiles don't have to go as far, so they tend to be a lot smaller.
लेकिन प्रमोशन के लिए पूरी तरह
Rockets
अनुकूल है।
tend to be
Minus
just
1
much
minute.
larger versions of missiles, essentially. And missiles aren't usually
Minus
staged,
2
so
seconds.
this one has like 3 stages.
प्रमोशन से
You wouldn't have that if you're
Minus
doing
40
just a missile.
seconds.
All sequences armed.
Minus 45 seconds. Minus 40 seconds.
Okay, then I'm wrong about the
Minus
Vicus
30
thing then.
seconds.
So ignore everything I said about Vicus. It's not the same as
Minus 30
what's on the
seconds.
solid rockets.
Real-time programs activated.
Minus 25 seconds. Minus 20 seconds.
Okay, here we go.
Minus 15 seconds.
Time to see some fire.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Here we go. Look how fast that thing takes off.
5 seconds.
It's a lot faster than a liquid rocket.
PT tracking.
R2 tracking.
P2 tracking.
That was a brilliant lift-off, a sight to behold.
Kind of takes off like a missile.
प्रज्वलन और सफलतापूर्ण उत्थापन SSLV D1 लॉन्च व्हीकल का। SSLV D1 EOS-2 मिशन अपने गंतव्य की ओर।
And you can see that
सभी
black
तंत्र
soot
सुचारू
trail.
रूप से काम करते हुए बहुत ही रोमांच का पल है ये। प्रथम प्रमोशन SSLV D1 का।
That's kind
Maiden
of
launch of SSLV. The performance of first stage is as per the prediction.
First stage performance normal.
that's good to hear.
Shar 1 as in main auto.
Plus 1 minute.
प्रथम
I'd
चरण
like them to
सामान्य
show that
निष्पादन
tracking
करता
shot.
हुआ।
Come on.
Shar 2 as in main auto.
So here-
वैज्ञानिकगण निरंतर नजर बनाए हुए हैं सभी आंकड़ों पर।
Here you can see the altitude versus
Flight
the speed, I
parameters
think.
and ground trace on your screens right now.
No, altitude versus the downrange distance.
Shar, Bangalore and Trivandrum telemetry stations tracking.
Wow, this thing is actually taking off quite fast.
प्रथम चरण का
I hope they don't just leave us in the animation screen the whole time. My goodness. Come on, ISRO. Show us some onboard footage.
This 22.5 meter long stage is powered by HTPB based solid propellant, 87 tons mass. It generates a thrust of 2600 kilonewtons. During the SS1 action time of 117 seconds, the altitude of the launch vehicle crosses about 85 kilometers.
So we should have separation coming up pretty soon here.
प्रथम
basically-
चरण के सभी तंत्र सामान्य कार्य करते हुए
That first stage will come off, and then the second stage will ignite.
First stage separated.
अभी अभी आपने सुना
So this one's
कि
pretty
इंजेक्शन की
instant. So
घोषणा की।
basically that
द्वितीय
second
चरण
stage
का
ignites
प्रज्वलन
almost
हो चुका है
immediately.
तथा प्रथम चरण को पृथक कर दिया गया है।
As per the announcement of the Range Operations Director, the second stage has started its operation, generating maximum vacuum thrust of 235 kilonewtons.
द्वितीय चरण का प्रज्वलन काल करीब 221
Payload fairing separated.
सेकंड का।
That's good to hear as well.
ऊष्मा कवच को पृथक कर दिया गया है।
Trivandrum and Port Blair stations presently tracking.
Plus 3 minutes.
अब हम 170 किलोमीटर की ऊंचाई पर आ चुके हैं।
So in about 30 seconds, we're gonna, or 30 seconds
There's
to
a
a
quick
minute.
succession of several flight events. The SS1 separation, following the SS2 ignition,
Second stage performance normal.
and
So-
then the closed interstate separation, initiation of closed loop guidance for the flight, and of course, the dense atmosphere and 100 kilometers altitude has been crossed. The payload fairing also has been separated.
So they're gonna go into a coast phase once they turn off this engine. So don't be alarmed.
यान की गति 3.35 किलोमीटर प्रति
Despite
सेकंड
that, the
तथा
rocket will
ऊंचाई
continue to
228
coast
किलोमीटर।
up to the, keep going higher and higher, and the trajectory will kind of change to be more parallel with the Earth, and then
Plus
they'll light
4
that third
minutes.
stage.
इस घटनाक्रम में SS2 का प्रज्वलन काल खत्म होने के बाद करीब 90 सेकंड का कोस्ट फेज होगा।
Second stage action completed.
So now it's going to coast for about 90 seconds before
Current
separating.
altitude is
Vehicle is in
260
combined
kilometers.
coasting.
So its
4
velocity
hours,
will kind of
4
decrease as it,
minutes 30 seconds past the launch time.
the velocity will just decrease a little bit here as it continues to coast upwards, and then it'll start increasing again.
इसे SS2 SS3 कंबाइंड कोस्टिंग फेज कहा जाता है।
Here you can see
इस
the
घटनाक्रम
altitude.
में अगली घटना होगी SS2
5
का
minutes.
पृथक्करण
So basically, they're going to coast until they get up to that 350
तथा
kilometer
SS3 का
range
प्रज्वलन।
zone, and then they're going to ignite that third stage.
Vehicle performance normal.
Is that Modi in the
यान पूरी
in
तरह
the,
सामान्य
in the viewing
प्रदर्शन करता
area?
हुआ
Pretty sure that's the president of
और
India.
अपनी उद्दिष्ट कक्षा की ओर बढ़ता हुआ।
It's always good to see the politicians involved in space.
Next flight event is the separation of the second stage, which has completed its
Second
operation.
stage separated.
Now
Okay,
we have
that's
got the
good.
confirmation that the second stage has been separated.
Third stage ignited.
जी हाँ,
Also good to
द्वितीय
see.
चरण अपना प्रज्वलन काल तथा कोस्ट फेज पूर्ण करने के पश्चात पृथक कर दिया गया है तथा तृतीय चरण SS3 प्रज्वलित हो चुका है।
So this one has a bit of a smaller diameter.
Right now the SSLV is in its third stage regime. The carbon fiber filament wound case with 4.5 tons of HTPB based solid propellant loading, SS3 will propel the rocket from 333.6 kilometers to 356.5 kilometers. A significant delta V addition takes place.
Yeah, it's
It is
about half the delta V.
3.7 kilometers
So
per second. That's the amount of velocity increase.
that little tiny piece at the top does half the entire work of the delta V change, which really goes to show you
SS3
the
का
effect of the
प्रज्वलन
rocket
काल
equation.
112 सेकंड का होगा। इस दौरान यह निर्वात प्रणोद 160 किलो न्यूटन का उत्पन्न करेगा।
Third stage performance normal.
इस चरण के दौरान ही कक्षीय स्थितियां प्राप्त की जा सकेंगी।
So you can see there the velocity
Plus
graph,
7
like
minutes.
how much that third stage is really doing. It's that third leg upwards. It's like doing essentially half the work.
Singapore and Port Blair stations still tracking. The action time for third stage is 112 seconds, after which there will be a combined coast phase.
That coast is just going to be between this and them activating the fourth stage. That's going to reorient and get them into the precise orbit that they want. Again,
Third stage action completed.
all right, that was quick.
तृतीय चरण अपना प्रज्वलन कार्य पूर्ण करता हुआ
Vehicle is in hosting.
She's in orbit. How about that?
Presently, it's the regime of coasting. The third stage has completed its operation, but yet to separate from the ongoing
8
launch
minutes.
vehicle. Control for pitch, yaw and roll being provided by the velocity trimming module thrusters.
It looks like they're a little bit off the nominal
In about 3 minutes
trajectory
of
here.
coasting,
You
there
can
is a
see
triple velocity addition and triple altitude gain.
their yellow line's a bit below the red one.
VTM will then operate and compensate for the velocity necessary for the injection of satellites and also the correct altitude.
So this is why they have to use that fourth stage to correct those little differences at this point. And that's just because the solids are not precise
इस
enough
साल को
to get a
आज़ादी के
perfect
अमृत महोत्सव
injection.
की तरह मना रहा है भारत के स्वतंत्रता के 75वें वर्षगांठ में पूरे भारत में तरह तरह से इसे मनाया जा रहा है इसमें सभी और विकास और उन्नति की दिशा को दिखाया जा रहा है यह
Yeah.
पर्व इसरो में भी मनाया जा
So you
रहा
can
है
tell they're missing
इसी
about
उद्देश्य के साथ मिशन
they're definitely missing
न सिर्फ एक नवीन प्रमोशन यान
about
प्रदर्शक है
20 to
बल्कि
50
मिशन
meters
के
per second at delta V.
सेट को आज़ादी के अमृत महोत्सव को समर्पित हैं
We are 9 minutes past the launch time. Combined coasting in progress right now.
I wonder why they coast so
यह
long.
मिशन एक और कारण से महत्वपूर्ण है इस यान में सफर कर रहे
What's this
आज़ादी
one?
सेट को हमारे देश के ही 750 स्कूली छात्राओं ने मिलकर बनाया है इस तरह यह मिशन महिलाओं को प्रोत्साहित करते हुए वुमेन इन स्पेस के थीम को भी सहायक बन रहा है
So if they didn't do anything right now, this thing would come back down to the Earth. So this is
BTM
why
velocity
they have to
trimming
put on
module
that
वह टर्मिनल चरण है
that,
जो कि
extra stage.
अंतःक्षेपण की पूरी स्थितियां प्राप्त करेगा
and this one's powered by liquids, particularly
Plus 10 minutes.
hypergolic liquids. So basically they ignite on contact. So it's also a pretty simple system. The only problem is that they're highly toxic.
You are watching us
So-
live from the Mission Control Center here at Satish Dhawan Space Center, Sriharikota. This is a maiden launch of SSLV D1 EOS-03 mission.
I like that Israel always has that viewing area. Like people watching the mission control. It's like you have fans, you know? A cheering section for the rockets. I wonder what you have to do to get invited into that showing room. Like, do you have to be a special person? Well, this looks good. They just started clapping. Okay, so they just had the separation
अभी आप
now.
ऑन बोर्ड कैमरा की मदद से देख पा रहे हैं
This is nice.
2 का पृथकीकरण तथा अंतःक्षेपण उसके उद्दिष्ट कक्षा में
And you notice that the vehicle was rolling a bit. I think that was to give the solid motors more stability in their burn. What happened? The vehicle's in orbit, so it's, well, almost in orbit. It has to do some corrections with its fourth stage bipropellant engine. But that looks like it's going all right based on the live footage. Looks like they're trying to give us the live feed from the
VTM
vehicle,
का
but it's
कार्य पूर्ण हो
difficult.
चुका है और इसे बंद किया जा चुका है
But yeah, the graphs tell us that they didn't quite get enough delta V for the first 3 motors, so they need that extra fourth stage to do the correction. So we're just waiting for that right now.
अभी उपग्रह के प्रमोशन की जानकारी आ चुकी है।
What do you mean by the
EOS-2
change in the
को
graph?
सफलतापूर्वक अंतक्षेपित कर दिया गया है।
Clapping is a good sign. I think hopefully that means that good things are happening. They should show us the graph again. Come on, show us the graphs again. Or the live
Following
feed.
the combined coast phase, the VTM ignition cutoff and EOS 0302 separation,
Perfect.
Azadi Sat separation, these flight events have taken place.
That's the end to a
जी हाँ,
successful
इसकी
mission.
पुष्टि कर दी गई है। EOS-2 तथा आज़ादी सेट को उनके उद्देश्य कक्षा में स्थापित कर दिया गया है।
So the satellites just separated there, which means that everything is finished for the actions for the vehicle at this point, I believe. Yeah.
The outcome of the mission is yet to be announced by the Range Operations Director.
I would like to hear that announcement before I say everything is perfect yet, though. Because, of course, they know that the trajectory is right or not.
मिशन की सफलता की औपचारिक घोषणा कुछ ही क्षणों में की जाएगी।
I always love these close-in zoom shots that they have of the mission control on these ISRO streams. They have some real cinematic value, you know. Well, it looks like mission control is not quite
Viewers can
satisfied
stay
yet.
tuned to the ISRO media portals to know the outcome of the mission of SSLV D1 EOS 02 mission.
I hope that the fourth stage piece worked properly. They never said anything about it. Basically, that's the only part of the mission that we haven't had confirmation of successful operation. So otherwise, this mission has been perfect. The solid rockets all did their job, got the vehicle into the trajectory it needed to be in. They just needed a little bit of correction from that fourth stage. And then they had the separation of the satellites. So hopefully the orbit is correct. I guess maybe the satellite's between ranging stations or something, so they're not really getting full data. I'm not sure.
Visuals from the mission control centers on your screens right now.
But it looks like mission control is not
Experts
satisfied
looking
yet.
at their monitors very intently.
आज़ादी सेट एक क्यूब सेट है जिसका भार करीब 8 केजी का है। इसमें कई सारे फेम्टो एक्सपेरिमेंट्स के लिए विभिन्न भार लगे हुए हैं।
The satellites did separate though, so there's nothing more the rocket can do.
इंडिया द्वारा एकीकृत किया गया है।
And the graphs look okay. But again, we wouldn't be able to tell the difference between whether something worked or not on that fourth stage, but looking at the graphs, because it has such a little delta V component that it adds.
अभी तक उपग्रह से संपूर्ण संकेत नहीं आए हैं।
One thing about the ISRO streams is they don't always give you a wealth of data. Like on SpaceX, they have everything. They have the velocity readout, the altitude readout. They have it all being tracked for all the stages, plus the clock and the running time, and they have a whole wheel that shows you all the staging events. Israel's a bit more Spartan with the whole process. Yeah, right now we're just waiting on confirmation that the satellites are in good orbit. Everything worked properly for the first 3 stages with the solid motors. So they got it into the right trajectory from there, but it needs a little bit of correction from the 4th stage, which is that hypergolic propellant stage that does some corrections to make sure the orbit is exactly what it needs to be to stay in that 350 kilometer orbit. So we don't have confirmation that that worked properly. So I don't know. I think the trajectory is fine though. It might just be that we're waiting for the satellite signal, and that could take a little while because basically the communication on the satellites has to open up and be working properly for that to work. But the satellites did separate, so that means that they're not part of the vehicle anymore. So now it's mainly the satellite's job to do what it's supposed to do. But we never had confirmation of good orbit or satellite health. So I think those are the 2 pieces of information that we're missing at this point. Although good orbit seems to be mostly fine because the rockets did their job as far as we can tell from the graphs. But they definitely like to hold us in suspense here. My goodness.
Good morning, all of you. The maiden flight of SSLV D1 just now completed. The SSLV's all stages performed as expected. The first stage performed and separated. The second stage performed and separated. The third stage also performed and separated. And we had in the terminal phase of the mission, some data loss is occurring, and we are analyzing the data. And we will come back on the status of the satellites and as well as the vehicle performance soon. So until then, please bear with us that we are currently in the process of analyzing the data to conclude on the final outcome of the mission with respect to a stable orbit achieved or not. So please please wait and we'll come back. Thank you so much for your patient viewing of this live telecast from SDS ISRO. Thank you so much once again.
So we will still be waiting on the stable orbit and satellite health confirmation, it sounds like. So they're not getting a signal from the satellite, basically is what that means. Hopefully, they will get something soon. They should get something when they start flying over. I think there's some ground stations in the Australia region. I'm not sure if they're flying over Australia. But once they go over the Pacific, basically, we won't have much information at that point. Because there's not really many ground stations around there. All right, well, it looks like that's going to be it for the live stream for now. I guess you have to check up on the social media to see when or if the satellites are giving back information on their orbit. So if you're curious about how that works out in the end, do check back in with ISRO. I think they have a Twitter you can follow. Or maybe they'll tell us here. Who knows? We'll stay on for a little while here until we get maybe another announcement. In the meantime, if you have any questions about the launch or the vehicle, do be free to ask. So far, everything has gone nominally that we know about. All 3 stages work properly. They delivered the payload and the 4th stage piece into good orbit, as far as we can tell. But we didn't get confirmation from the satellites that they're in a good orbit, so the satellites aren't communicating, which could be for any number of reasons. Doesn't necessarily mean that the satellites aren't working. It could just be that they are out of range of a ground station and didn't open their antennas in time. So it's not a huge issue yet. If you're just joining the feed now, hi. The launch just happened, so you have to rewind a bit to see the launch itself. But everything has worked out okay so far as we can tell. There isn't a problem yet that we know of. So basically, there's been no confirmation of a problem. I don't think there's a problem with the rocket itself. I think the rocket did its job properly. I think what's happening here is that the satellites are just not talking to the ground yet. And that could be any number of reasons. The satellites, of course, need to open up their antennas to communicate with the ground. And if that doesn't happen before they're in range of a ground station, then you might not get signals from them immediately. Of course, a lot of the rocket's trajectory, or the satellite's trajectory, is flying over like ocean and stuff, and there's no ground stations in the middle of the ocean, so you won't necessarily get immediate communication. But as soon as it flies over a ground station somewhere around the world that ISRO has connection with, then you should see, then they should be able to confirm that the satellite's in the correct orbit. Data loss does not mean that it's not in the correct orbit. Data loss just means they don't communicate with the satellite yet. So it could be that they're not in the correct orbit, and that's why they can't talk to it, because they're looking at the wrong spot. But I would say that's a little bit less likely. The most likely situation is that the satellite is just not, the communication part of it is not communicating back to the ground station properly. Yeah, if we are in the wrong orbit, then it would be purely the fault of that 4th stage. Maybe it didn't work, didn't come on properly, and then basically we're basically in the wrong orbit then, and then we might end up, crashing back into the Earth because of the atmospheric drag. But I don't think that's what happened. Of course, we don't know till we have a confirmation from ISRO. I think it's just that they're not talking to the satellite yet. Hopefully that's what's happening, because it would suck to miss by such a small bit at the end. That wouldn't be very good. Also, the system that they have for that 4th stage is pretty simple. Like it's just hypergolic propellants. So they literally just have to open valves and the thing turns on. So it seems kind of unlikely that they'd have an issue there. But who knows? Maybe there's a sticky valve. Anything can happen, right? But still, I think most likely they just are flying over the ocean right now and are not going to get communication with those satellites until it starts flying around over land again. Yeah, I'm not really familiar with the Chandrayaan-2 vehicle. Does it also have communication issues? Yeah. It depends. It also depends on how many ground stations you have access to. Like, so, for instance, like if you're an American launcher, like you usually have access to a lot of ground stations, just because America exists in a lot of the world. So they have ground stations in Europe, they have ground stations in North America, they have ground stations in like Hawaii, they have ground stations in Australia and in Africa. So like if you're an American launcher, you tend to have access to more tracking stations. I don't know how many tracking stations ISRO has access to, so it could just be that they only have a couple in like the Asia region, and then, if it's flying, around the back side of the world, well, they're not going to see it. Yes, right. Sorry. That is the moon mission that they had, where they were trying to land. Is that what you're talking about? That was a little bit different. They also had a communication loss, yes. But they actually had a mechanical problem with like the engines shut down early and it basically crashed into the ground. So they had orientation issues there. You could see on their cast, like the vehicle was like spinning around, which is not good. So that was more than just communication. Of course, we lost communication when it crashed into the ground, but there was clearly something wrong with the propulsion and orientation systems on Chandrayaan-2. So there was no indication of this on this vehicle, because we even saw the live feed as it separated from the vehicle. And in that live feed, like, we didn't see any indication that there was a control issue. It was gently spinning, but that's normal. Solid rockets usually spin a little bit in order to balance out their thrust. So like that's normal for the third stage to be doing that. Can you change the orbit of the satellite with onboard motors? That's actually a good question. Usually the satellites have some sort of propulsion modules on them, but the thing is they're really weak. So if they didn't get, let's just speculate that they didn't get that kick from the fourth stage engine. Basically what that means is that they have like a lot of delta V to make up, because those are supposed to provide 50 meters per second of delta V to the vehicle. And that's the difference between an orbital altitude of 350 kilometers and one that is like 100 kilometers and going into the atmosphere. And the thing is that the onboard propulsion modules on these little tiny satellites usually aren't powerful enough to make up for that in time. And so essentially the satellite will crash in the end. So usually the onboard the propulsion on the satellite can't make up for such a big difference. So I would say that if the fourth stage didn't come on at all, then basically this mission is doomed. But there's no confirmation of that, so don't speculate just yet. Yeah. Anyways, it's great to see that the SSLV finally got to launch. I've been waiting for this one for a while. It's been on the launch manifest for some months. And it's good to see that most of it has occurred successfully, and most likely, I think all of it will be successful, but we just have to wait on those satellites communicating back to the ground station. Yeah, I would like to thank you all for joining, and I hope that you learned a little bit about the SSLV launch vehicle, and hopefully you're inspired to continue following the space industry and maybe one day get involved yourself. This is how innovation starts here. Just watching a launch might inspire you to eventually maybe be an engineer sometime and start building rockets yourself. So definitely, if you're looking for that, just go and try to pursue it. It's out there, and there's lots of space for people to start innovating in this sector. So yeah, we need more support. Yeah, it looks like, you can probably, if you go to the N2YO site, you can definitely try and track the satellite. I'm not sure, do they have it already in their satellite tracking there? If they do, that probably is a good sign. So, but otherwise, check in with ISRO for official confirmation of any events related to the satellites. So they're ISRO satellites, so they'll be the ones that make the final call. Anyways, I'd like to thank you guys for tuning in, and I hope you guys have a wonderful day, and congratulations to the SSLV for performing nominally, at least for the rocket part of it anyway, for the big solid rockets. And I hope that you continue to expand your horizons.